Let's take a look at problem 7 from sample test 3. In this problem we have two boxes with marbles. Box A has 2 green and 5 blue marbles for a total of 7. Box B has 9 green and 6 blue for a total of 15. In this situation it says we're going to be drawing a marble from box A, transferring it to box B, and then choosing a marble from box B. And so once we draw a marble from box A and transfer it to box B will then have 16 marbles that we'll be choosing from. Remember, depending on the color that we choose from A, that's going to change these numbers in box B. The question here is asking us to find the probability that a blue marble was drawn from box A if you know a green marble was drawn from box B. So we're trying to find the probability of blue out of A given green out of B. Now, since green out of B is actually going to be the second event, then we really can't figure this directly. This is actually the reverse of what we can figure out by using our probability fractions. And so that's where Bayes' theorem comes in, because remember, Bayes' theorem is what allows us to find a given probability if we know the reverse of it. So in this situation, I will be using the probability of green from box B given blue from box A on the top of the fraction, and remember that the other part of this product needs to be the first event that happens, blue from box A. The bottom of my fraction for Bayes' theorem needs to contain all of the ways to get a green marble from box B. Well, those are that we can pull a blue from A and then get a green from B, given that there was a blue in A. And my other option is the complement of this. The complement of pulling a blue from box A would be pulling a green from box A. And so this second part is going to be the probability of green from A times the probability of green from B given green from A. Once you have your fractions set up, then it's just a matter of figuring out what's going on here. And so the first part right here is the probability of pulling a blue marble from box A. Well, there are 5 blues out of 7, so that fraction will be 5/7. Next we have the probability of a green marble from box B given we chose a blue from box A. Well, remember, whatever marble I choose from box A is going to change the total and that color in box B. So I now would have 7 blue marbles in box B for a total of 16. Out of those 16 marbles, though, 9 of them are blue, and 9 of them are green, and so that fraction would be 9/16. On the bottom, we know that we have the same 5/7 and 9/16 for the first product. And then here I need to look at the probability of getting a green marble from box A, which is 2 out of 7, times the probability of getting a green marble from box B given there was a green marble chosen from box A. So again, if there was a green marble chosen from box A, I would be transferring that marble to box B, so now I would have 10 green marbles out of the 16 total marbles, so that's going to be 10/16. And so if I look at all of my fractions here on the top, I would have 45 over 7 times 16 is 1/12. On the bottom, I would have 45 over 1/12 plus 20 over 1/12, so that gives me 65 over 1/12. And so looking at this, If I have 45 over 112 over 65 over 112, that's the same thing as having 45 over 65. And 45 over 65 reduces by dividing each of those by 5 to 9 over 13, which is in fact the probability of getting a blue marble from box A given we chose a green marble from box B.